Let's listen Mr. Valentin Răduț. Mr. Valentin Răduț from Computari System Architect, and the speech will be about the directory structure, the heart for subscriber data management application. Mr. Valentin Răduț. Oh, welcome.
Hear me? Right. So, hello everybody, ladies and gentlemen. Thank you for having me. And my topic today is going to be subscriber data management, and one particular solution for handling that. Subscriber data management is a term coined a couple of years ago by, well, let's say 5 years ago, by network operators around the world to name a platform, a general platform for storing and delivering information about, well, what else? The subscribers. So, right. Well, the first thing that came to mind when I was asked by my colleagues to do this presentation is, but it's a very specialized, topic. There are only a couple of companies in the world who provide professional software for network operators, because it's such a sensitive subject. And so that was my first concern. It's a specialized network operator problem. But then I realized it's actually not, because it used to be a specialized network problem, but it has evolved so much over the past 30 years, along with the actual data which is being processed, that it is no longer a specialized network problem. It's a data management problem, obviously, because you have a lot of data to contend with. And by a lot of data, I know a couple of guys in the room say, well, this guy is contending with a couple of terabytes, and we're still trying to figure out a word for what we call our data range. But it's not only the volume, as my pre-speakers pointed out. It's a lot of other information that make it big data. So it is a big data problem if we talk about database, but now the hype is to move it in the cloud, and obviously you have data access speed and high availability, and those are actually our biggest challenges. But let's talk about why I'm actually presenting this to you. I'm presenting this to you because it's a big market, and it's a very fast growing market. I was comparing it with the mobile apps market, which, well, everybody's aware of, and well, you probably are consumers of mobile apps. And that's about a $5 to $7 billion a market, and it's very crowded. A lot of people are investing there. This is a lot less crowded, and look at its growth. You can look at just the blue one, because it's the mobile network market, SDM for mobile networks market. And that one is already at $1.5 billion, and it's increasing at a very steep rate, because the technology is changing very rapidly there. 60 years ago, we were probably still calling numbers in London by saying, connect me to London 23. Right now, I have about 4 subscribers back home. I have 2 cell phones, I have a couple of data plans, and so on. So those are all subscribers. We all have them, we all use them, we pile up data very fast on that. So, and this is growing. People who first standardized this industry 30 years ago never expected it to grow that fast, never expected to change the architecture that fast. And it's already changed 3 times. We were 3G, and now we're implementing 4G, and the 5G standard is already on the way. Oh, by the way, feel free to interrupt me at any time by raising your hand if you have a question about anything, and I don't know, probably the nice lady who helped the other guys will bring your phone, or I'll just repeat the question. So now let's get to the problem statement. What is SDM, Subscriber Data Management? Subscriber Data Management is a platform, as I said in the beginning, but who's it serving? So the first guys who take advantage of the SDM are the network elements. So actually the core network. If you want to be connected to someone over the phone, you need to, the network needs to find out information about you first. It needs to query your number, your phone number from which you're calling, and it needs to know that you have credit, enough to make a call. It needs to know that the other guy actually exists on one network or other in the world, and then it needs to make the connection between the two. And all of these are querying the SDM. And of course, you have third-party applications which are plugged onto to the network, and then you have the operations part. The network itself needs to do a front desk and sales. It needs to credit your account. It needs to send out bills and things like that. And you need to be able to change your account settings from a CRM or a self-care portal. And also, one of the most important parts, it needs to monitor how it works. This is particularly important with LTE, which is long-term evolution. It stands for long-term evolution, is the 4G standard, because voice over LTE is basically voice over IP, and you no longer have a dedicated channel for that. So you need to monitor and perform a QoS of whatever is going on in the network at all times, in order to make sure that the network is functioning correctly and your customers are satisfied, are happy. So now, taking that aside, what are the challenges? Well, the first thing is that this industry has been around for a lot of years now, and the fact that it has changed didn't mean that it moved from one technology, from one architecture to another. So whatever you design and whatever you implement in the network industry, in the communication industry, you need to make sure that it will be still usable after 30 years. We still use 2G, and I'm sure every one of you has experienced 2G and didn't see any difference, because you just go out of 3G coverage, you get 2G coverage, and you talk just fine. You can do that while talking. So you go out of 3G, you go into 2G while you're talking on the phone, you don't see the difference. But when you look at your phone, you see that the reception is 2G in that area. And this is one of the biggest challenges. The SDM has to provide the same information, or have the same core information, but provided over different services. For instance, as a fact, 2G has a concept which is called the HLR, which is the home location register, and it used that to store all the information about all the users. The IMS, which is in IP multimedia subsystem, which is used right now for VoLTE and other services, uses something called an HSS, which is a home subscriber service. And these are two different animals. They don't look alike. They don't have the same services. They provide completely different interfaces, but they still use the same SDM, and they have to use the same SDM, because obviously you can't have different information about the same subscriber in two different technologies. It would lead to chaos. Obviously, it has to have scalability, because a network is relying on a constant growth. It says, I will expand my services, I will expand my client base, and my architecture needs to be able to cope with that in terms of data storage and service. You have to have high availability. Usually when a catastrophe happens, you will notice that the communication services are among the last ones to fall. You will have communication services when pretty much you don't have electricity. Obviously, you need redundancy and resilience for that. You need geographical distribution, because if one node fails for any reason, you need to be able to rely on the other ones. You need to have automatic failover, and all needs to happen in real time. And now, by real time means something in the order of milliseconds. When you're not connected to the other guy in the next couple of milliseconds, or where your speech is stuttering during your call, you have bad service essentially, and you're going to complain about that to your service provider. And obviously, it also happens concurrently, because a lot of guys are making calls at the same time, especially on New Year. So you have to support that and be able to balance your data access to support that. And the more, let's say, recent evolution in that, you need to expose your interface to other guys to develop their own services, their own architectures, their own software, without knowing in advance what they're going to use it for, what they're going to do with it. So someone comes to the network operator and says, look, I have a great idea. Romanians who call for free to Canada, all right? And the network says, okay, what do you need? Well, I need access to your SDM, because I need to know who they are, those subscribers. And I'm going to sell them a card, which is my card, but you don't put it in your phone. You still use your, I don't know, Cosmote or Vodafone, sorry, T-Mobile, Vodafone card, but you're using this particular service to call for free in Canada. And to do that, the network operator needs to provide this interface to the SDM in order for third parties to plug in their services in there. Now, let's see how this was done until now. We were talking about HLR, which is the 2G technology, and the HSS, which is the IMS technology. The classical approach, and the one which has been around until the SDM was coined as a concept, was to have 1 DB, 1 application, and have them replicate each other in time. And obviously there were advantages to that, because if one service failed with its own, along with the database, the other services were still up, and it was fine. People didn't want to depend on each other on this one. But then people said, okay, why don't we create an abstraction layer? And actually this is the big step forward, which is the base of subscriber data management. You have an abstraction layer over some DB or another. It doesn't matter that it's one sort of DB, another sort of DB, if it's big data or not big data. You have an abstraction layer which is used by everyone, by all the applications making use of subscriber data. And now we come to big data, and I'd like to thank the guys who talked before me, because they actually said these words before, like complexity, velocity, variability, volume, and I think the volume is the least important part here. As I mentioned, there isn't a whole lot of data. So the guys were talking about petabytes, they were talking about petabytes per hour. Here it's, let's say, terabytes maybe for a big operator. But the volume is only the one thing which makes it very hard to work with. It's not the challenge. It's not the elephant in the room. The elephant in the room is the velocity. Data needs to be transferred very fast. And the one thing that saves us actually is that not all the data needs to be transferred very fast. We need a particular set of data and a particular kind of query at all times. We know that. We will always query by the number. So the guy calls, we need to know who that guy is. We query by that number, the MSISDN we call it. Or then of course the IMSI, which is a unique identifier. So this is a kind of an illustration of what I was just saying. The first way of doing it is having different apps with different databases replicating each other, and there's a reason why those arrows have different lengths, because each application needs a different response time from its database, although the database contains basically the same information. Now in here we have a front end, FE stands for front end, and BE for back end. We have a front end connecting to a series of applications, and the front end dispatches requests to the back ends, and the backends contain the bulk data. And now we come to our solution, to how we handle this problem and the technology that we used, which is a directory structure. The directory structure is naturally optimized for this kind of scenario. A directory, well, you see it in your laptop, of course, because your files are organized in a directory. You also probably see it in, I don't know, email and other corporate user organization systems. You query it via LDAP traditionally, but of course you can query it via a different number of technologies and interfaces. It's naturally optimized for this hierarchical way of querying and organizing the data. Basically we have the user, and that's the core information that we need for querying and for applying various procedures on the network elements, and then you have all the other information structured underneath the user. And it's easy to distribute and scale, as because it's a network directory structure actually. It's able to accommodate a lot of eclectic data, unstructured data, because when you come up and say, okay, look, I need a new plan for our subscribers, and this plan needs to take into account the session, so how many minutes they have used that thus far, how many minutes they have received from other users, and we need to do that only, I don't know, for the first 6 months of service. After 6 months we need to cut that off. And we need to put that information, which is completely different from anything we have put into the tree so far. We need to put it because the client asks us to. And say, you don't have to, you shouldn't modify the structure of the database. You don't have to add new tables, new things like that. But I want this to be implemented nonetheless. And you can put that because in a directory, just attach another leaf or attach a completely new tree by linking it to the user, and that's that. You got it. You can change the schema on the fly, but that's something that happens when you change technology. Obviously, when I don't know, go from 2G to 3G or to 4G, and you need a whole new structure. You can patch additional functionality on top of the existing system, and the most important thing is everybody knows the interfaces, and you can provide them in a variety of manners, like LDAP, SQL, whatever, and people can read it. That's not being said that people will actually read the directory structure itself, because probably they won't. The history of what we are using is that there were these guys, a startup called Apertio, who created the network directory structure, the network directory structure 1, they called it, and eventually Nokia Networks took them over, and now they are part of the SDM built by Nokia, which is incidentally the market leader in SDM at this moment. So the fact that it's backward compatible with older GSM networks says that actually older GSM networks use directory structure and use LDAP to query information about their users, and this goes way back. It goes before GSM existed. I mean, think of it this way. The first telephone networks were using an operator who was doing something, and I'm going to quickly demonstrate it. So you want London. Okay, I have patch here, and I'm going to connect it to London. And you want 2, and I'm going to connect 2, and then you want 3, and I'm going to connect 3. And so the switching was done in basically a hierarchical way. You choose the city first, and then the region, and then a particular subscriber in that region. So later on, it became traditional to query in a hierarchical manner the users, the subscribers. And so LDAP has become a household technology. That's what I mean by backward compatible, because right now the SDM is providing the service itself. It doesn't need compatibility with the network elements themselves. And obviously forward compatible with the upcoming LTE and whatever comes next, the 5G, because we have a wide variety of APIs, and because the platform itself is open to adding new APIs to it. And this is these are a couple of words about the Nokia product that I've been mentioning. It's based on the X500 directory, which is the standard in directory structures. It's highly distributed. It has obviously a hierarchical tree-like structure because it is a directory. As with the previous picture, it has a front end, and it dispatches requests towards the back end. As I was saying before, it supports a variety of open interfaces. Those are just a couple of them. And it is deployed in a number of network operators, a rather large number of network operators around the world. Here are my references, and with that, I would take your questions, because nobody dared to ask them while I was saying things. I think I have a big elephant question that I will address anyway, even if nobody asks it, but go ahead.
Sorry, have you tried to address other companies, let's say, that are not only in the networking area?
Are not the only, sorry?
Not only in the network area, like Vodafone or others.
Ah, I see. So trying to apply this particular architecture in other fields. Well, the network directory structure is obviously an open repository for data. And so yes, it can theoretically be applied to other fields, but this is so particular to the type of query rather than, I'm probably not going to compete with the DS against, I don't know, NoSQL for unstructured data, for querying that unstructured data, or for querying, complex, for having complex queries that should run faster. But I'm going to compete against them anytime on addressing the data from that common point, from that node that is the subscriber identifier. So it is very particular to this scenario. And if you can give me an example of another area of technology that uses the same or similar scenario, then yes, it's obviously a good idea. Now, SDM is specific to network operators, the SDM idea. Now, the directory structure is not. Obviously, email is a good example. I don't know, the Exchange is using something like that. A lot of user organizing platforms are using LDAP as well, and directory structures. So it's not specific, the directory structure. The SDM is kind of specific because it was built for that. And it integrates several services which are specific to network operators.
What is your opinion about delivery as a service?
Well, actually, this is a service. This is basically, at the same time, an API on which people can develop their own applications, and they can use the functions of the SDM, but it's also a service. It is in its own right a service because a lot of, so let me come back to one earlier, yeah, this one. Okay, so of course these are all services. Some of them are directly connected to the SDM. They are attached to the directory structure. They are querying LDAP. They are doing LDAP queries. When a guy goes to Vodafone Shop, for instance, and they ask for more credit, the guy taps directly into the SDM in order to do that. Of course, there's a front end to that, but basically the service is the SDM. There's no application, well, depends on the choice, of course, but there can be the direct tap into the SDM, and that's the purpose of the SDM, to provide services for a lot of applications. And one thing that, so not all of these are using the network directory. Of course, the monitoring, for instance, can say I'm only accessing the information as far as, I don't know, the subscriber, the activity of the subscriber, the activity in the same day, the activity per hour or something like that, and then I'm storing all the information, I'm caching it, because I want a big report. A big report asking, for instance, how many data package loss, how much data package loss was incurred during the last 5 months, for instance. You can't query that into the network directory structure, you're gonna kill it. But you can do that in a, I don't know, an RDBMS, for instance, because you're storing exactly the data you want, or in a NoSQL environment, because you're storing unstructured data. It depends on your choice of technology here. But so the SDM is just to provide very fast data about the subscriber data, the subscribers themselves.
Thank you.
Thank you, guys.